So I'm going to do a couple of examples to hopefully help you out, one in each category. So I'm going to do number 2. Given g of x equals negative 2x squared minus 4x plus 6, we need to graph it and then find this following information. So to find the vertex, remember that is x equals negative b over 2a. So that's going to be a negative 4 over 2 times negative 2, which is a 4 over negative 4, which is a negative 1. Then once you find that, you plug that negative 1 in back into the original equation. So that's negative 2 times negative 1 squared minus 4 times negative 1 plus 6. And when you do all of that, you will get a positive 8. So let's graph that. So make it a little bit bigger. Negative 1 positive 8 is here. And then we know that the a value is negative 2, so the a is negative 2, and depending how you learn how to graph this, there is a shortcut. You can use the pattern 135 for a quadratic, but you have to multiply that a value to the front of it. So since we have the a at negative 2, then it's negative 2 times 1, which is negative 2, negative 6, negative 10. So instead of going right 1, up 1, which is the pattern for a regular x squared, you're going to go right 1, down 2. Then you're going to go right 1, down 6, which is right here. And then right 1, down 10, which is here. Okay, and then you reflect it across the axis of symmetry. So let me draw that axis of symmetry here, and then you make a smooth curve. Okay, so now we're looking at, is this a maximum or minimum? So it's a maximum because it's the high point here. This is your max, and that is at when y equals 8. Right, or you can just say 8. Y equals 8, or 8's fine. You can say the vertex, negative 1, 8, so either one. The axis of symmetry is your x value of your vertex, which is x equals negative 1. The domain is all real numbers. Your range, you can write this in one of two ways. You can say the range is y is less than or equal to positive 8, or an interval notation. You can say it's negative infinity to 8, and it does hit that 8 value, so that is closed. Increasing, so you want to look at where is this increasing. So it's when it's going up. And so that is increasing to the left of negative 1. So you can say when x is less than negative 1, you can say to the left of negative 1, or you can write it in interval notation, negative infinity to negative 1, right, the x value here. Then it's decreasing on the other side here, so that is when x is greater than negative 1, or you can say it's from negative 1 to positive infinity. It's decreasing in that interval. The next thing we need to take a look at is when it's above and below the x-axis. Okay, so let's look at when it's greater than 0, we're looking at when it's above the x-axis here. So again, we're doing it in respect to the x value. And so we know that it's above when x is between negative 3 and positive 1. Then we look at when is it below the x-axis here. Here, we're looking at the y values, or when the y values are negative, right? So that's when it's below the x-axis. So we know that is when x is less than negative 3 and when x is greater than positive 1. Okay, so that is how you do this problem. And then just as a reminder, when you are checking these out, you can tell when this is correct, like your graph is, remember this is the y-intercept. So, and it does hit at positive 6. So my vertex was at negative 1, 8. I did my pattern, and then I checked my y-intercept, and my y-intercept is at 6, so I did graph it correctly. So this helps for number 2.